Wait for some people to join. Excuse me. Wait for some people to join in. Hey, how's it going? Thanks for the letting me know the sound works. So today, I'm making a programming jig. I've already designed it, so I'm just doing the PCB. Basically, again, it's to do with this little module. I'm working on the Kickstarter right now, but in order to do the Kickstarter, I have to have some of these made and have some demo boards and all that, like I did last time. So let me, oh, wrong camera. So I've got this already made. It's a little programming jig. And basically, this is the chip. This board goes in there. And it's got some springs, and this is a little 3D printed part, this piece here. And these are some aluminum cylinders that I have a whole bunch of. And this bottom piece is the PCB. So these will be bolted in, bolts and nuts. And when you put the chip in here, it's going to center it, and you can push the whole thing down onto these pogo pins. And there's going to be some like programming things in there that I can touch, and then I can upload the bootloader, and hopefully I can do it really efficiently and fast. And yeah, it's kind of necessary if I'm going to be doing a whole bunch of these, so might as well make your own. So I've got this board, and I've got the drawing made up. So let's open KiCad, close some programs. And hello everyone. If I didn't say hi already, welcome to the stream. Yeah, I don't really see any issues with this other than there might be some alignment things, but I think it should be good enough. It might take a few 3D printing trials to get the tolerances just right, but it's such a small part it would take like maybe 20-30 minutes tops to print it. So I'll be able to get it just right and not have to worry about that. So let's get this project going. Get some Twitter stuff going, get some more viewers hopefully. How is everyone doing today? It has been insanely hot around here that I don't know, it's not normal. It's been over 30 degrees consistently. Almost hit 40 yesterday, I think. So I'm staying inside in the air conditioning. What's up, AP Tech? How's it going? Just doing the usual, spamming some social media stuff so we can get some more viewers. So just give me a second. Yeah, I don't know what's up with the weather. This is crazy. And we'll just get some Instagram people in here. Let's see what they're doing. Hey, what's up everyone? I'm doing a live stream right now on building a programming jig. And there's the camera and the viewers. So if you want to join me, come to my YouTube channel, youtube.com/SeanHodgins Come check it out. Hey, what's up everyone? I'm doing a live stream right now on building a programming jig. And there's the camera, there's the viewers. So if you want to join me, go to my YouTube channel, youtube.com/SeanHodgins Come check it out. Hey, what's up everyone? I'm doing a live stream right now. Yeah, it's going to be, again, for that module I was talking about before, because I'm hopefully going to be making a whole bunch of them once I get the Kickstarter going, so it's kind of like gotta do all the steps before I do the Kickstarter, and one of them is to have some of these modules working so I can film it and show how it works, and to do that, I need something to program them. It's like all these steps, as usual. Whoa. Alright, let's get things going. Close some stuff. Alright. Copy of our project. Should have done all this stuff before, but you know how it is. So where's everyone viewing from today? Usual? Hey, what's up, Tim? Yeah, I don't think anything else needs to be added on this board. We're going to be putting an Adafruit trinket, one of these, on here because it will allow us to have a power supply, and also I can put a button on that will have like a macro that will run the programmer, which would be kind of cool. Oregon, what's it like in Oregon right now? And hey, how's it going? Thanks for coming out to the stream. So you're used to Fusion. Okay. Got that. Programming jig. So I always just copy my projects over from other projects. And this means that like my library is up to date and everything, but it also can, any problems that were from the last project will also copy over, and they tend to build up sometimes. So I'll copy it over and I'll change the name so it says programming jig, but this was a breakout board I was working on Sunday, 2 days ago. So it'll have all that stuff in it. If we open it, you'll see. This was what I was working on Sunday. And it was just a little breakout board for Canada Day. So this is what it looked like. I'll show you that before I erase everything. Starting harvest. What's I guess it's a lot of work. What are you harvesting? I think I remember seeing a video on it, but I don't know if it was the same stuff you're going to be harvesting now. I like KiCad. I started with Eagle, but it was limited, and I like that KiCad is open source, and then and that there's no real limitations. So this is the board that I was working on Sunday. It's a breakout board for this module. I'll show you. It's a little Canadian flag. It's kind of cool. And this is what it will look like as a board. Well, hopefully not like that, but full screen color, white. Mouse color is red. Yeah, it's simple. So I'll delete all this because it's from the other project. And I'll import the new board. Oh, I do. Oh, green beans, my favorite. I hope you're making a video on it. I'd love to see how green beans are actually harvested. get rid of that BRB. There it is. Oh, and I gotta change the title. Noob here. I'll get rid of this dimension too. Alright. Yeah, I should use that more. I tend to just take it out when I have to do like 100 of something. Got the board file here, and there we go. And all these sizes should be correct as well. How's it going, Brian? Alright, so deleted that. And I don't think we need any of this stuff for what we're doing. No. So we'll delete this as well. I think. Yeah. Gone. Delete that. Hey, Vulcans. Alright, what are we going to put in here? So we're going to throw a trinket on, but I don't think I'm going to use an actual footprint for it. I'm just going to use like pin headers with the names. So it's got 5 and 5. So we'll put in those headers. Good weather in Ireland. It's not extremely hot like it is here. I think it's like 38 degrees right now. I think the hotkey thing he was talking about was the one I made on my channel. Mirror that. So we'll call this trinket left. Trinket right. So these are just going to be the pins for the trinket. So we got like 5 on here. We're just going to stick this right on. We're going to use the voltage regulator from the trinket, and we're going to use it as a hotkey as well. So let's just label these for fun so we know which side. That. Ground. And I'm just taking the labels right off the trinket. Yeah, they're super easy to make. You take a trinket, you connect it to a switch that grounds, you set a pull-up resistor, you run the program that makes the trinket a keyboard, program in what keys you want it to simulate, and that's it. When it detects a button push, it works. I'm just putting the names of the pins on here. instead of making an actual trinket footprint, we'll just do that. Yeah, it was a quick little project that I made to use some buttons that I had hanging around and to kind of speed up something I had to do where it was repetitive and I was programming something and thought it would be an interesting project for people to see. Alright, what's next? So we need pogo pins, and I've already sourced the part. Right now we'll just get test points. So we'll just use these. What we're going to do is use 5 of these. We'll label them what they're going to be. So one's going to be 3.3 volts, ground. It's going to be reset. One will be SDIO. Grab a board here. There it is. Just forget the names. Oh yeah, SWDIO. Just to keep it consistent. And the programming clock. And same with the connection. No, actually I don't know why I'm putting ground. Put a real ground. And a real 3.3. So for anyone who's just joined the stream, just like last time I was working on something for this little module thing. The SAMD module, which is an upcoming Kickstarter, and I need to make a device to program it without having to solder some jumper wires to it. I need to do that before I can make the Kickstarter video, and I need to do a whole bunch of things, so I'm going to try to get it all done so I can order some circuit boards. So we'll copy the reset. And hey, how's it going? Alright. It's kind of a big sheet needed for this. So let's change it. Change the date. Bootloader programmer. CC. Yep, always new projects. Let's go for, there we go. What else? We need a button. Last time I couldn't find a button in my library for some reason. So why don't we make one just for fun? Thank you. Let's see if there's one just missing for no reason. Yeah, we'll just make a button for fun. Why not? So let's just load anything here. Alright, thanks for coming out, and yeah, keep forgetting that I was going to build something. What am I talking about? Oh yeah. I was going to send you one of my projects, but I still haven't gotten around to it. But I think it'd be cool if, like, you wanted to collab with some electronics and some of the stuff you do. If you're interested. Everyone, you should go check out Rainfall Projects as well, because he does some really cool stuff and makes really good videos that are really relaxing to watch, so head there. Yeah, KiCad, they all have their challenges. I think Eagle works a little bit better, but I like the fact that KiCad's open source. So we'll change this. Alright, let's make a button. You know, actually, I couldn't. Everything I learned from watching YouTube videos, taking apart people's projects. Yeah, and just forcing myself to get into it. So I honestly don't know any books off the top of my head that would be helpful. This board is for uploading a bootloader to the SAMD module I'm making. Go to this library editor, and we'll set the library to, I don't know, analog switches? Sure, why not? New component, tactile switch, Not really sure why mine don't show up anymore. And we'll make a little switch. Pin on here. One. Looks kind of silly, but that's quick. Or let's do it a different way. Actually, move this. Yeah, I tend to learn by taking things apart more than anything. Does that look better? So we got a little switch there. And I put in analog switches because why not? Should be in the library now. Tile switch. Kind of big, but whatever. We're learning. So I need to pick a pin. I'm pretty sure any one of these pins can be interrupts. The switch is going to trigger a macro so that it can do... I'm putting the trinket on. And the switch will be able to like mimic a keyboard so that when I have Atmel Studio open, I can make it hit upload or program or something, or I can make it do a whole bunch of things. So if I put a few buttons on this board, then it'll just make my life easier, and I can just stick the module in, press the button, program, take it out, put a new one in, take it out. Keep doing that. I can also, yeah, I can't really program it after I've done that, but that could be a different set. So we'll just make, we'll throw a couple of buttons on, maybe 3. We got room, I think. Hey Noah, how's it going? Three switches. I hope so. Basically what you want to do is always just have the least amount of button pushes and clicks and mouse movements as possible. So we'll attach. Could actually have up to 5 buttons on here, but that's probably unnecessary. Actually, we'll leave 3 and 4 in case we want to use the UART. It's a good idea. So it detects when they push the chip in. And think about that. I guess I could connect one of the I connect one of the programming lines. Buttons are pretty cheap too, so I'll have the buttons on there anyways. And then I think if I wanted to add touch, I could probably do that through one of these data lines. Oh yeah. Yeah, that makes sense. I'm not sure I'll wear mine out, but I guess it's possible. They probably do a lot more boards than I do, but it's definitely something to think about. You can actually do capacitance without even using the chip. You can just use it on a pin and using a resistor. I've done it before. I can't remember exactly what's required. I think you take 2 pins and a resistor, and then you just measure like the rise time of the capacitance when you touch it, something. TTP 223. Maybe I'll implement that in version 2 if I end up wearing out one of these switches. It's alright. I'll do it in version 2. It'll give me something to update if this breaks. Right now we'll just make this simple. Got 3 switches like that. We don't need a USB port. Oh, we need the programming header. That's the other thing we need. These resets are different. I don't even need this one. That's ugly. So I have an Atmel ICE, which has, here it is, which you use to put the bootloader on. It's got this connector and I have a whole bunch of these, the male ends of these. So you just stick this on the board. I'll just plug this into this board and then plug this into the computer as well. Probably the easiest way. And I'm actually going to open up a project that already has it in it, so I don't have to mess around. I think this one does. There it is. So what I'd like to do is close this. Right click. Instead of copy, you go to save block. This is in EE schema for the schematics. So you save block on this one. Then you open the new one. And you click this button and you paste it just like that. Now the connector is missing. That's fine. We'll save this. Go back in here. It'll say the new connector. OK. And there it is, slightly off center. Alright. So that's the debug connector. Yeah. That's everything so far. And I'm going to have to make a custom footprint for the spring contacts I'm using. Let me bring those up. I think it's these ones. So I'm using these ones here. Those. Alright. And those are actually modeled. I modeled them into Fusion. So those are under there. And these can compress into it. Yeah. And a lot of these parts I have laying around. And the 3D printed part, obviously, I can make. So that's why I chose this design. These aluminum cylinders, I have a ton of them from that Pixel project. So I might as well use them. And yeah, I've got a million buttons on hand, and I've got the screws and the nuts. So that normally defines a lot of the reasons for doing certain things. Okay, so let me make a footprint for these spring contacts. Close this. Footprint editor. Actually put this in project footprints. Footprint name. Pogo pin. Sure. Very unspecific. And it's just going to be one pin, but we have to get the exact drill dimensions. So we'll look at the so these are supposed to be surface mount, but I'm going to put them through a hole and have them mount on this edge. That might even be the way you're supposed to do it, I'm not sure. So we see here 0.64 diameter, that's inches. I do everything in millimeters, I tend to. So let's see. So the drill, what is that? 0.64 times 0.54. So that's 1.625 millimeters. So we'll go might be too big. That's not the drill. And the bottom piece that will have the solder on is 0.8. We'll go 2 and see how that fits on the board. Should give us enough room to solder. And I mean, these aren't, I'm only making one of these, so if it's not super durable, should still work fine. We'll see how it looks on the board. I'll save this in the project lives. Alright. Now we should be able to add the parts. Actually, I'll make a quick trinket part as well. No, take that back. Just going to use headers and we'll just space them appropriately. Okay. Okay. Trinket left, pin headers. So we're going for straight, 1.1 by 5, 2.54 pitch. Do both of those. Now the pin headers, or the pogo pins, it may not show up. Oh, there it is. So the 5 of these. Then this pin header is already in. It's 2 by 05, pitch 1.27. That's what this is. Oh, there we go. And the 3 switches. Which be hard to find. Can't remember what I normally use. Electromechanical. I really need to clean up these libraries one of these days. I think that is what I need. Alright. See if we can think of anything else. And if someone in the audience want to try to come up with a name for this board and a logo like last time, and hopefully we don't crash the program, which almost happened last time, which was awesome. But managed to fix it. Okay. Forgot to hit net, as usual. Now we can go bring all the parts in. Hit this button, set it to the different viewing mode, and spread out all the footprints. Let me go back to normal mode. Take away the grid because it's annoying. And let's move the origin. To where this is. Close enough. Alright, so these are all mounting holes. And then these are the locations of the pogo pins. Hopefully they fit near each other, or we might have to move some stuff around. They should fit. Alright. Now I need to figure out which pin goes where on my old board. Close that. So we'll bring that up, we'll get an image of it. When we close all this, save, save. Show you the module. So there's the tiny module, and we got from top to bottom 3.3, ground, reset, clock, I/O. So break that down. A little notepad here. Close it and go back. Start with 3.3. So center. And center. Put it right on top. And that's what's awesome about doing the CAD in Fusion before actually making your PCB. What's next? Ground. Center 127. What I'm doing here is I'm just copying and pasting the center points so that they're exactly where they're supposed to be. And I'll delete those board edge marks first, once they're all placed. Center, X, center, Y. Everything working well on the stream? Audio's working? Chat's not being delayed or anything? Clock. These ones might be a little bit close, but I think it'll be alright. Good. Hopefully we have room for all these buttons. You can always make this wider without actually changing the CAD model if I wanted to. If I move everything over like 5 or 2 centimeters or something. We'll see how it fits. So the trinket spacing for these, a 1/2 inch. Yeah, it's a 1/2 inch. And I said inch because the pin spacing is imperial. So we'll set these locations in the Y direction somewhere around here. So they're the same. And I can also see that the pins are correct. Now the spacing between them, this one I'm going to go 50, and this I'll go 12.7 away from that, so 162.7. Now that'll put the trinket right here. How big is it? It's about 26 millimeters. And 8 from the bottom pin. So we could throw some drawing lines in there if we wanted to, just so we know where it's going to be. So 8 from this, 9116 will be 9916. And yeah, delete that little thing. So that's where the bottom of the trinket's going to be. Double check that. And then it's 9 from the top. So if this is here, that's 81. And it's going to be 72. So copy this. Duplicate. We'll go 72. That's where the top's going to be, but it's going to be lifted off the board because we're using headers, so this screw won't get in the way. Hey Nicholas, I'm good. How you doing? So we're going to put this header on here. Now this outline is not the correct outline for this header. The actual one is see, 13.5, no, 12.7, so it's a ½ inch wide. So we have to make sure it doesn't interfere with the both this and the trinket. I guess I could put it at the top also. Dropping stuff all over the place. Alright. So yeah, I could easily put it here. Lots of room. So why don't we do that? And I'm just making sure it's going on the right way. Put that around there somewhere. So the cable's going to come in here, attach, and we'll push down here. Now we got lots of room for the buttons. And I don't know, could I fit them here? Don't want my finger to be in the way when I'm pushing down on the programmer. So again, let's look at this. How do I measure in this? That's giving me the angle, but where's just the coordinates? To each other. Anyways, I think it'll be fine. We'll double check. Oh yeah, plenty of room. this one in the center. Let's see. Why that 118? All in line. Where's this positioned? This is at 104.39, and the whole board is 60. What was that at again? So we're going to go 164. Half of that. 134 should be right in the middle. And that's 149, so what is that? We're already 15. 15 seems good. We'll go less. Alright, those should be centered. Still trying to think of a name. We got a nice spot here to put a logo for this programmer. Rotate that one. So we have the grounds down there. That was confusing for a second, but that's the name of the pin. Here, you can see where the connections are. Oh, I've named the reset wrong. See, so that's something that can happen. So this is called reset, R-E-S-E-S-E-T, and this is called RST. And what happened was they're named differently, so you don't see that they're not connected. And if you have a whole bunch of pins, that can happen. You can just miss it. You can go to this unconnected. It's going to say everything here because we haven't done it yet, but it wouldn't show up in the unconnected because it has no rat's nest to it. So you would that would just be a mistake if I didn't catch that, and I'd have to run a flywire to it or something. But I did see it, and I can fix it now, but that's just an example of how when you copy and paste things, what can happen. So we'll change this one to RST, save, and we'll redo the nets. We'll go back in, read it, and you'll see now I've got a connection there. Let's get rid of that. There we go. So we've got so much room to do whatever we want, which often makes it more difficult for me to decide how to route things, but this won't be an issue. Surprisingly, I just found out about this feature of moving traces about a couple of weeks ago, and it's quite the lifesaver. I don't know why I didn't know about it before. Or I had some setting that I didn't have selected properly. And see how we have 3.3 volts going to the programmer and to the trinket? Well, here's the thing. This doesn't supply power to your chip when you're programming it. It's probably some type of safety thing so you don't fry this, but you have to give it power, which is part of the reason for using the trinket. It saves me some time from having to put a voltage regulator on here or plugging in some other USB. So the trinket will take care of all that, and we'll just run this over there. And then the buttons can go directly to the button side. And I'm going to change that order also. So I'll go to the top. One, two, three. And 1, 2, 3. So they're reversed. This is just me being OCD. It's not absolutely necessary. But it's nice if you can't decide how to do certain things. You see here it went through the, doesn't detect that edge. Not really sure why. So we'll just move that. So we'll just redo it. Okay, so how's that looking? Yep, these will obviously be, get my call. So that's where the trinket will go. Got the 3 buttons. We got plenty of room for something else if we want. But I think that should work nice. And if anyone can think of anything else to add, let me know. But all we're doing is programming these boards. And we don't really have any other connection to them. Yep. Should be good, and they're on the right side. So if we take this, flip it down, and that's where those are going to be. Okay. Gotta throw something on here. Love seeing tweets about the Pixel. It's really cool. seeing what people's projects, what they're working on. Really enjoy that. Okay. Let me add logo. Right up here. Actually, I gotta keep out. So what I'm doing is getting rid of the copper layer here, because it actually makes the logo look a little bit cooler. So that's the mask, but then I add my own copper back on. And what that does is and that's another thing, is if you don't hit B, which removes the copper layer. Hey, where'd that go? There it goes. I don't know why that wasn't working. If you don't hit B, then it doesn't update the copper layer. And yeah. You can order your board with errors. So it just makes the copper pop a bit more when you take away the copper layer. It's kind of cool. I wonder if there's a way to do a keep out with a design. I haven't really looked into that. There definitely is, but I don't know. We'll call this something then. Load up Photoshop, import some image. Two centimeters, 2 by 2 at 1600 pixels in centimeter, or no, 1600 pixels an inch. HCC, that's the name of the module. Oops. Get rid of that. 10. Anyone got any ideas for a board logo and or name? Love to hear them. For some reason it's difficult for me to like be more creative on stream. It's a weird phenomenon. I guess because I'm focusing on a few other things. Like last time when I did the Godzilla, the Modzilla board, the logo didn't work out as well, and then as soon as I was off stream I had a way better image idea, and I found some vector art of like a dinosaur or a Godzilla, and it's way cooler than the one that almost crashed KiCad. I want to call it like the boot commander or something. I'm guessing most people are probably at work, so you can't be too involved in the stream, which is cool. Let's see how much room we got here. Right? Measure. Yeah, so 2 centimeters ish, which is what I chose. That trumps. Yeah, I don't know about that. Ooh, just fits, perfect. The wig loader? What's that in reference to? I'm gonna look up some. As soon as you mentioned the wig loader, that made me think of that Simpsons episode where Homer's hair is making him do bad things. I figured that's what it was, but I was just making sure. So now I'm thinking it's a shot of that hair. Something like this. Would be kind of funny. Let me see. There we go. That, or I could actually get a booty loader. All these references of These boards I'm making on LiveStream, no one's going to know what the heck I'm talking about, which is good. So let's load up Illustrator. Load that image. Photoshop. Do some quick isolations here. I was wondered about all these new tools in Photoshop that I never use. Sometimes work really well, like subject. Look at that. Didn't have to do anything. That's crazy. We'll get rid of some other stuff here. Can't believe how well that worked. Oh, 21 viewers. It's the highest so far. Just making a logo for the board we just designed. Where is it? Let's recall it. I decided to call it the boot commander. Then we had some WIG references. And then I started thinking of Homer Simpson's toupee that makes him try to kill people. So that's where we're at. And I just opened Arduino. Toupee. Okay. Trace that. Now we got more colors than that. Let's see here. We can do a few layers here if we wanted to. We could do this in copper, this light part, and then this with no mask, this with mask, and then the outline with silkscreen, right? Or this with silk. Yeah, that's what we'll do. This will be no mask, the black. So let's go color. We want Hopefully that works. Smooth everything out. I'm going to have to do some more Photoshop work here. Maybe I'll do the whole thing in Photoshop. Let's go back in there. Darken these. It's kind of funny how these KiCad streams turn into Photoshop. Let's expand these a little. Fill this a few times. Physically draw some of the other stuff in. Let's see. I've got a weird pen selected. So once we get this image edited, I'm going to show you how to do like a multi-layered image from it, where you can use solder mask with copper, solder mask without copper, silk screen, no solder mask with copper, and no solder mask with no copper. And with those, you can make pretty cool images. Right now I'm just fixing up the outlines here. That's a little bit more solid. I actually have a drawing pad, but I rarely take it out. Since this has 1, 2, 3, and 4 layers, we'll make use of them all. Might as well. Let me just crop this guy. Probably losing viewers because I'm not doing KiCad stuff anymore, but this is part of it. Gotta have fun too. So we'll isolate each layer by color. So what's next? So that's good. Again, we'll pull this one out. And fill that with this color. Hide that one. And then we'll take Now we're being kind of quick with this, but might as well. Copy those. Fill that. And then we'll take the yellow. That should be all the layers. Do this one manually. So for this yellow, we'll actually use the copper layer. Okay. So let's save each one of these. Save this one as put them all on the desktop. Okay. Copper. This will be silk. This will be copper, right? And this one, we'll see if we can do keep out somehow. What's this one? More. Perfect. Okay. So we'll export this. To images. Make it 1600. This one. So we're going to do a trick to KiCad, since you can't actually make these, you can't actually make a copper layer with the program. So if we open up the bitmap2 component, and we'll start with this one, the silk screen. It's huge, but that's fine. So right here it tells you how big it's going to be, and it's right now it's 5.3 centimeters by 6.4 centimeters. So we're going to go up to see how this looks. In fact, I'm going to load a different one first. Load number 3. We're going to make it 1.7 centimeters by 2 centimeters. See if that'll fit. And my picture. Front solder mask. Now if we export this, it's just going to go into this project's library. I'm going to call it PC and we'll call it, this is going to be the KiCad, I guess. Now we're going to actually open this file in Notepad++. Hello. How's it going? We're just working on a logo for this board we just made, in case anyone's wondering. And this is to program the bootloader onto this new module that I'm making. We open this with Notepad++. You see it's a silk layer. We actually chose solder mask. Okay. And we're going to modify it so that it's actually a different layer. Thank you. So you can actually change these. The trinket is a version of the SAMD21. The SAMD21G is this. It's the bigger one that I use for most things. But the trinket is SAMD21E, which is even tinier. So it's not a 32U4, but it's faster and can do the same things, basically. So actually, I'm going to save this as silk screen, export, name, save, yes. So you guys see here it says fsilk s. We can actually change this to whatever we want. Now I don't know what a keep out is labeled as in KiCad. But if we want, we can make it 2. Let's see. We go to the project lives folder. Their footprints. Now let's just load up a logo. Go there. And let's change it to, what do we just call it? BC. Oh. So yeah, so it's the wrong way. Oh, it's completely disappearing. That is the silk screen. I guess we got traces going through here, so we're also going to make it smaller. Just going to look up real quick, see if you can actually make a keep out layer. Because I think it doesn't work the same way as the other ones do. Yeah, can't see it right off the bat, so I'm not going to spend too much time on it. But I have a better idea. I don't like how this program, you can't zoom, I don't think. Okay. See this size. Let's go smaller. There we go. I gotta think about this for a second. I'm gonna do the design. So we have that one, and this one. And the name. I'll just do that one. All right. Move this back into Photoshop. Yeah, that's Snake's hair. Good eye, too. All right. Alright, we're just about done here. This part was completely unnecessary, but I like to do it anyways. Export. Well, it's going to be underneath. Hate these trial and error type things. I could probably just measure it right off the bat, but you know, what's the fun in that? All right. And I'll throw a little mask on there. By keeping everything to the same proportions, that means everything will line up when you put it in after. Alright, after all that work, we just end up with this. And I'm going to move up the trinket a little bit. Okay, that's it. Another board to order. So that will hopefully work out, and I'll make a video on actually building this and showing you how it works at some point in the future. But that's it. Simple as that. Cool, so I don't think it needs anything else. If you guys don't see any problems with it, then I'm sure it's fine. Connect the trinket up, make sure all the pins are right one last time. And go ahead and order this later. So, it's a quick stream. And yeah, I think that's it for today. Thanks everyone for coming out. Hopefully we'll do something a little bit more interesting next time, but yeah, it's fun. Might as well stream while I'm doing something. Anyways, everyone, I'll catch you later, and yeah, thanks for coming out. See ya.